Hi, I'm Mr. Franklin, and welcome to Conceptual Physics. Today we're going to be talking about graphing in science. Many of you are most familiar with graphing because you do it in math a lot. The main difference between graphing in math versus science is math graphs for a general case. They're trying to teach you the process. It's usually an infinite case covering all the possibilities for that equation. When we do graphing, we are going to be talking about a physical property that is being described by the graph. So our graphs, we're going to actually be reading our graphs and pulling physical data off of it. We're going to be pulling physical information and seeing it's going to mean something for us. So that's the big deal with what we're going to be looking for with our graphs. So first thing we're going to do right now is we're going to set up this little page right here. It's graphing steps and examples. This is going to be done on graph paper, so you're going to need a piece of graph paper. You're going to need to fold it in half. You're going to put the title, Graphing Steps and Examples, and then we're going to write the steps, which I'm going to go through up here on the board. Okay. When you finish, we're also going to work two examples. You're going to glue this in your comp book, and mine's a little off, but you're going to want to glue it so that you can close your comp book, and then you can use this on your test when it's time to graph, and so you have your steps for you. Okay. While you're writing this, if you run out of room, because some of you will run out of room, if you will just go to the back and write the next couple steps, because that way you can read them. Okay, that's where you should write the next thing if you run out of room for these steps. The examples will be in your composition book. They're more to help you understand what the steps are, and you won't be able to use those on your test. Okay, so let's get started. So first I'm going to just go through these, kind of explain what it says, and then we're going to actually do it. Step one for graphing is identify the independent variable and the dependent variable. Step two, we're going to use our ruler to draw an x-axis and a y-axis. Even if we're on graph paper, we want to do that. We want our graphs to be as precise as possible. Sometimes we're doing labs where we're on a blank sheet of paper and we don't have graph paper, so we're going to have to create our graphs. We want to be as precise as we can. Step three, we want to label the axes of our graph. The x-axis should be labeled with the independent variables variable and then the unit. The y-axis should be labeled with the dependent variables variable and unit, and I'll show you that in a second. Step four, put a 0 on the x-axis and the y-axis at the origin. So the x-axis and that y-axis, when we draw our graph, are basically two different number lines that represent two different values. And so each one requires a 0. Okay? Step 5. The x-axis, we're going to place values evenly. So we're basically going to put our numbers on the number line, and we're going to place those values evenly spaced for the x-axis. Okay? So now I'm going to adjust the camera so you can see the next part of this, which we're going to talk about the y-axis. Okay. So the y-axis is a little more difficult because it's a measured thing. We can't guarantee that it's going to be evenly spaced. So the first thing we need to do is count how many squares, if we're on graph paper, or figure out the space available. And then we're going to decide how we're going to skip count. Are we going to go 2, 4, 6, 8, 10? Are we going to go 5, 10, 15, 20? How are we going to skip count to cover all the values in your data and use all the space available on the y-axis? Okay? Step 6 is the easiest one. We're going to plot each point. We're going to read the x-axis and then the y-axis and mark our points. Step 7, we're going to draw a line of fit. We're going to use the ruler method. We're just going to place our ruler down and see where our ruler touches the most dots. There's actually other ways to do it, but that's how we're going to do it. Step 8, we're going to title our graph. We're going to put dependent variable versus the independent variable. We're actually not going to put dv versus iv. We're actually going to put what that variable is. Okay? So, get all that written down, and then we'll switch over to the other board and do our examples. Thank you. Hello, I'm Mr. Franklin, and welcome to part 2 of our graphing video notes. In this video, we're going to use our graphing guide that we created, and we're actually going to create 2 basic graphs. Okay, and then after we do this, I'll give you some more to practice with. Okay, so first thing we should do is Step 1, identify the independent variable and dependent variable. So our independent variable in this case is time. So how do I know it is time? Because it is the x-axis. The x-axis is where we put the independent variable. The independent variable now has a name, and it is called time. That means this is the dependent variable. So the y-axis is not called the y-axis anymore. It is called the distance axis. So our y-axis has a name. We call it distance. So step 2, use your ruler to draw an x and y axis. I already used my ruler. I already drew my axis. When you're doing this on your graph paper, you should count, let's see, 1, 2, 3, 4. So you should count 8 squares. So every 2 squares, we're going to make up, so you should count 8 squares. So 8 squares across, 8 squares going up, and you will have the right size on your graph paper. Okay, so we've drawn our axis. Now we're going to label the axis with the variable and the unit. So the x-axis, our independent variable, is time, and we're going to label it with the unit just like that. So we put the variable, and then we put the units in parentheses inside, and then we're going to do the same thing with our y-axis. So the x-axis is not called x, it is called t for time. And our y-axis is called d for distance. In the next graph, you can already look ahead and you're going to see that these variables are different. And so our axis may have different names as we continue to progress through the physics that we're going to be learning. Okay, so step 1, we identified the IV, dV. Step 2, we drew our axes, 8 squares, 8 squares. Step 3, we labeled our axes, and now we're going to put a 0. This is step 4. We're going to put a 0 on the x-axis, and we're going to put a 0 on the y-axis. Why? Because this is time. So when we're doing an experiment, we're going to have 0 seconds. 0 seconds is not the same thing as 0 meters. Okay, so that's why there's 2 zeros, because the 0 is a different kind of 0. Okay. Step 5, place values for the x-axis, place them evenly spaced. So we've got 4 values, so we're going to count every 2 squares, and we're going to make a mark. And now we're going to label these. So we've already got 0, we've got 1 second, 2 seconds, 3 seconds, 4 seconds. Now, these numbers are numbers that we choose because they're the input to the experiment, so they are exactly what goes on this axis. We just want them evenly spaced. Okay? So we're skipping, we're skipping a line here and going to the next one. We're evenly spacing them out. Okay, now the y-axis is a different story. So if you read your thing on the y-axis, it says count how many squares are available. And we said, I told you to do 8 squares. So you have 8 squares. 1, 2, 3, 4, 5, 6, 7, and 8. So you have 8 squares. That's probably where you're stopped, right there. 8 squares. Here, I'll go ahead and fix this one too. 8 squares. We go all the way to 2.1. So what would be a good number to go by on our axis, skip count by, to make it work? I'm thinking 0.5 might be a good one to go by. So we could go 0.5, 1.0, 1.5, and 2.0. Go ahead, you can sit down. Okay? So notice these values are not exactly on the graph. Okay? So we're going to skip count, and we always start from 0 because it's a number line. Okay. So that's step 5. This is should be the only part of this that's really challenging to you because you have to do a little bit of thinking. The rest of it is just paying attention to detail, taking your time, and just writing it down. The next step, We are on step 6, plot each point. So we got 0, 0. We've got 1 and 0.5, which is about here. We've got 2 and 1.0. And then we've got 3 and 1.2. Oh, 1.2 is not exactly on where we want. So there's 1. There's 1.5. Halfway is 1.25. So it's going to be just a little bit under halfway. Okay. And then number 4 is 2.1. So it's all the way up here to 2, but it's actually slightly above. Okay. So we've plotted our points. Okay. Next step, draw a line of best fit. Now, if you look this up and Google it, you're going to find all kinds of fancy ways to do this. We're going to keep it simple for this class. We're going to use the ruler method. You're just going to take your ruler, okay, or straight edge, and you're going to line it up with as many points as possible. Okay? And where does it go through the most points? So it's about right there. Goes through most points. I'm going to draw the line of fit. If I can keep my ruler from moving. Okay, draw the line of fit, but notice I have 2 points that are not on the line. Okay, so that's why this is going to be the most number of points. Eventually, we're going to have lines of fit that won't even go through the 0. Okay, you're going to have a y-intercept. Imagine that. Okay, so find where the most number of points go through it. You're going to draw the line. Now, this is one of the major differences between this class and math. In math, you would keep drawing that line and then you would add an arrow at the end, but we do not put arrows. Why? Because at 4 seconds, I stopped measuring. I don't know what's going to happen after 4 seconds. I can make a prediction, but what happens out here, I don't know what's going to happen. Okay? So we need to be honest with our data that we're collecting in our experiments, and we need to understand that we're guessing if we go beyond that. So no, we're going to stop our lines at our last collected point. Okay. Next, I actually usually do this first, but it is last in our list, and I put a title on our graph. So the title of this one is dependent variable, which is distance, versus, that's a VS in case you can't read my writing, versus time. Distance versus time is the title. So what did I do? I took this and I flipped it. D and T, and I flipped it. Distance versus time. Okay? So let's recap. So this is kind of how I grade when I'm grading your graphs when you do these. First thing I look at is title, dependent variable versus independent variable. Dependent variable, independent variable label with units, zeros on the axis, numbers, these are exactly from the data table and they are evenly spaced out. These numbers are evenly spaced, there's a skip count, and they are not necessarily these numbers. I plot that you plotted the points correctly, and then I check if you drew a reasonable line of fit. Everybody's line of fit may be slightly different, but they should be similar since for our test, it's going to be the same data. So it should be reasonably close to that. And then the title, I'll check that. That's 8 points on your test. So honestly, zeros, there should be no reason to miss that. You just put them. Labels, no reason to miss that. There's 4 points already, okay? This, you should not miss that. Some people struggle with the spacing on this, but you should be fine with that. This is probably the one area where I expect you to see some mistakes, but hopefully you figure it out and it will be fine. Okay, all right. So here's another one. Here's this data table. What I want you to do is go ahead and write this down, pause the video, and try it on your own. but then watch me do it. When you're done trying it on your own by yourself, unpause the video and watch me work through it. Okay? All right. Okay, welcome back. Let's graph this. I'm going to kind of go fast just so you can see how this should work. Okay? So, first thing, IV, DV. I'm going to label my axis before I forget. Time is the independent variable. Mass in kilograms is a dependent variable. I'm going to put my 0, 0, and 0. Okay? And then I drew this one every 2 squares, just like we did before. Okay. On your graph paper. Okay, this one, 0, 0.5, 1.0, 1.5, 2.0. This one, 1,000 is the highest value. So I want this top value to be 1,000. So I got 1, 2, 3, 4 values. What would be a good skip count? I could go 200, 400, 600, 800, 1,000. I could go 100, 200, 300, 400, 500, 600, 800, 900, 1,000. Or I'm just going to do 250, 500, 750, 1,000. So you also, not only do you have to think about it, you also have some options. Okay? Okay, now I'm going to plot my points. Now this is where people usually mess up. What does the data say? 0 and 1,000. So 0 and 1,000. That point is way up here. Okay? 800. That's slightly above 750, so that's about right here. But that's 0.5, 800, so that's going to be over here. Okay? And then we have 1.0 and 600, 1.0 and 600, so that's slightly between those two. I'm thinking I should have skip counted by 2s. Okay, and now we have 300, 1.5 and 300, which is down here. And then 2.0 and 189. 189 is kind of down here. Okay. Now I'm going to draw my line of fit. Do the ruler test. It looks kind of like this. Might be my line. Your line might look slightly different depending on how you skip counted. Okay, but not all the points, like this point won't touch the line, and this point may not touch the line. Okay? Okay, title. Mass versus time. So I want to really point out that just because this has 1,000, notice how this number line worked out. We always start at 0 at the bottom and then count up to 1,000. But if you read the data and plot the points, what is the result? So this one had a positive slope and this one resulted in a negative slope. Okay? So because of this, it's really important that you follow the steps. Okay? Don't think, oh, I got this, and you're running through it, and then you plot something that looks like that when it should be this one. Okay? So be very careful. Take your time with these and follow the steps. Okay. So now you have a couple to practice in Google Classroom, and then after you finish that, you will work in your packet on some more graphing practice. Okay? All right, thank you.